Hi, I'm David Davis from Actual Tech Media. We're here at VMworld 2018, and I'm excited to be joined by Mr. Roberto Mari. He is the Director of Product Management at Barefoot Networks, is that right?
That's right, David.
Thanks for being on Actual Tech Media today.
Thanks for having me here.
Yeah, so Barefoot Networks, I've heard of you all. I know that you all have been on Tech Field Day and are actually going to be on Tech Field Day again tomorrow. So if you're watching, make sure you check for that video. But for those who don't know or haven't heard of Barefoot Networks, let's start off by just telling us who is Barefoot Networks.
Okay, Barefoot Network is a startup company. We are based in Silicon Valley in Santa Clara. Okay. And we have like a group of people from hardware, software expertise, different field of networking. It's fundamentally a networking company. And we work on an amazing technology. Our product is called Tofino. It's a programmable chip. So imagine you have today this fixed function chip that can do networking with very well-defined set of features. Imagine now you want to go and change that, change the way the data plane process packets, introduce new protocols, build that specific device, networking device for the specific scale that you need in your data center. Now all of this is possible thanks to our chip and thanks to a programming language called P4, which is a high-level programming language, nothing like microcode. It's more similar to, in fact, like a C or C++. Allows the user, enables the user to become an author and define the specific data plane processing they want to do for packets.
Wow. I mean, that's really revolutionary. I mean, because traditional network hardware has ASICs specifically designed to do specific things.
Yes.
And you don't really have control over the operating system that runs that network device.
Correct.
Other than the configuration. So with your chip and the P4 programming language, I can essentially define my network or create a programmable network. Some people call it infrastructure as code or whatever term you want to use, but I can define how my network works essentially. Am I understanding?
That's right. You can do that. There are multiple users, class of users. This is very powerful for the customers that want to become author and they want to become author of these P4 programs. This is also powerful if you buy this technology from the OEM. So think about the system vendors that use our chip today. Today we have companies like Arista and Cisco that ship products using the Tofino chip. So now as a customer, you can go to that system vendor and ask for a specific feature. Instead of waiting for that merchant silicon vendor or new ASIC to come out, which takes typically years, you can get the new feature at the speed of software, at the speed of a new release. It's that simple. So you can author yourself that P4 program, or you can use an OEM to author that program for you.
So I can compose my network, composable networking. So what are some of the use cases? How is this helping real companies?
Yeah, so the use cases are various, right? So the beautiful things about the P4 programmability, it adapts to the customer's use cases. So what we are showcasing, for example, here at VMworld this year is an amazing technology called inbound network telemetry. And the inbound network telemetry now gives to these customers the ability to instrument metadata into the packet to track performance issues that are happening in the network. And instrumenting the packet gives you the ability now to monitor issues at the per packet level. So you move from a flow-based technology, where typically you do monitoring using flows, to a technology where you can monitor these performance issues looking at packets. So even as smallest issues like a packet drop, which is today only reported via a counter, is reported via a more comprehensive reports with more analytics, more information. If you have a microburst, for example, that lasts like few microseconds, these microbursts can be detected very easily by our data plane. And alongside with the data plane, we also sell software to our customers. We have an analytic software called Barefoot Deep Insight, which is a big data analytic that will harness all this telemetry from this data plane and build intelligent analytics to give these customers very easy workflows to troubleshoot these issues.
Wow, so with massive, terabit networks, all this data flowing, it's not possible anymore to stick a tap on the network. Like I went to Network General Sniffer University back in the day and download data and try to do packet analysis. you guys are doing this at a massively higher scale, much higher volume of network traffic, and you're able to do it on a per packet basis.
Exactly. So that's the revolutionary thing about the Deep Insight and our inbound telemetry. We can monitor terabit networks. We can instrument these packets. This intelligent data plane will only generate a report when an anomaly is detected by the data plane. So this allows the whole system, the analytics and the telemetry, inbound telemetry, to scale to terabit networks without deploying clusters of servers. What we are showing here at VMworld is the Deep Insight analytics running on a single server form factor, which is the starting point for where most customers want to, explore the technology, start deploying into production. Of course, this is a scale-out application, so they can grow if they want.
Very nice. So we're here at VMworld. There's a lot of talk about, SDN and VMware's NSX. So I'm just curious, how does this interface with NSX in some way?
That's a great question, and I'm very familiar with NSX. I used to be part of the VMware team and part of the NSX team. The use case there, we are working with this virtual switch integration, and the use case is very simple. So today you have great visibility with technology like NSX in the overlay space. You can trace where these packets are going through that logical networks. You can trace them to the VNIC, to the logical firewall, to the logical router. As soon as the packet crosses the underlay, most of this technology lose the ability to monitor this packet. You of course have technology to monitor the physical network, but you miss the kind of single pane of glass on monitoring virtual and physical together. So with inbound network telemetry, with NSX support and Deep Insight integration, customer will be able to get that correlation between virtual and physical, so to detect, for example, hey, if I'm losing packets for my virtualized application and this is a problem in the physical network, where that problem is, how can I remedy that problem?
Very nice, very nice. So, I'm personally interested in trying this out for myself. I'm curious, is there an easy way for people to get started? Is there a virtual switch they can use in a lab environment? What do you recommend?
Absolutely, absolutely. Customers can go and grab and ask Barefoot for a virtual model. So we have functional virtual models of Tofino, which is our chip. We also have ASIC accurate models, so they can start with these models. They can use Mininet to build networks. They can do very simple verification with the models. And if they are interested in exploring beyond the functionality, they can acquire one of those reference systems that we have. So we have white boxes that can be bought from white box vendors that customers can use for the implementation. And of course, we also have a number of system vendors. I mentioned Arista and Cisco that are selling these boxes to enterprise customers.
Very nice. Thank you so much for your time today, Roberto.
Thanks. Thank you.